we have reached the point where we're going to start talking about linear functions. And what are linear functions? Well, they're functions that when you graph them, you're going to get a line, a straight line, as opposed to a curved line or a wavy line or any other kind of line. And the other really key thing about linear functions is, as you can see in the first point, a linear function has a constant rate of change. The slope of the line is constant, all right? And as it says in the second point, its graph is a straight line. And as you may recall, a rate of change is the same as slope. When you hear the words rate of change, you're thinking slope y over x. And then we are asked a question, pardon me, here, by way of example. Does the relationship in each table represent a linear function? And I'm going to show you these two tables. I've got two examples. And we're going to look at them and see if, in fact, they do represent linear functions. So I'm going to try and make this a little bigger. Let's see what happens. All right, hopefully those numbers are a little easier to see. And what I am looking at for here is a constant rate of change. So let's look at what I'm talking about. When I compare the y to the x, is it the same each time? All right, I've got 2 to 0, 4 to 1, 7 to 2, 8 to 3, all right, 10 to 4. So let's look and see. Notice that between the 2 and the 4, the distance between here and here is 2. Between here and here is 3. Between here and here is 1. And between here and here is 2. Here, on the other hand, I've got 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, and 3 to 4 is 1. So take a moment, and do you think that this represents a function? Is the rate of change constant? Okay, let's see if you were right or wrong. Here's my explanation. All right, and as you can see, here are the rates of change. As we said, in between the x values, the rate of change is a 1 in between each value, and it changes for our output or our y values. From the first to the second, you've got 2, the second to the third, you've got 3. And I'm going to slide this over so we can read what I wrote as a note. And what it says is, this is not a function. The rate of change, pardon me, the slope, wow, that's kind of hard to read. Let's let an angle like that. Why don't we try this? This one-take video making makes for a lot of interesting filmmaking. All right, this is not a function. The rate of change, the slope between the pairs of values is not constant, right? The slope between here and here, that's 2 to 1, as you can see, and then it's 3 to 1, and 1 to 1, and 2 to 1. So as I wrote, the rate of change from the first pair to the second pair, and what I mean by pairs is of ordered pairs, is different. It's not consistent. Okay, I'm going to slide this up so that we can look at another example. Actually, I'm going to pause this for a minute, and I'll show you another example. Okay, let's take a look at this input-output table, x, y values. We are looking at the slope, or the rate of change. Those terms are interchangeable, and let's see what they are. What do we have here? All right, so between this value and this value, we have an increase of 1. Between this value and this value, we have an increase of 1. Between this value and this value, we have an increase in 1. And between this value and this value, we have an increase in 1. All right? So what do we have here? Between 5 and 8, that value, it's 3. 8 and 11, it's 3. 14 and 17, it's 3. So what we have is a constant rate of change. The rate of change between these things is equivalent. And this is a function. All right? And this is why I know it's a function. I'm looking at my x values. The distance between each x value or input value is 1, and the distance between each of my output values is 3. So as it says, this is a function. The rate of change between values is constant. It is 3 to 1. Okay, and that's what a linear function is. Good thing to know. You're going to need this.